So there are two things here. One is, I'm going to have like a bucket, like 1,000,000 or something, or 100,000, whatever. But I'm going to have enough, and they're going to occur in this proportion. That's intensive property. Intensive property means, I only had 100,000 oxygens. I'll have to multiply that tenfold. So let's have 1,000,000 or whatever. It's a 2-to-1 ratio, so it doesn't matter. It's just going to be in that ratio, in that proportionality. And so I'm going to grab the atoms out of there and build the molecules. So this is going to be the most abundant one. And then tell me how many other ones are there? And so there are two questions. One, I don't care what the abundances are. I'm just going to figure out all the combinations. So did you figure out how many combinations there are? Not yet? Okay. So figure out how many different combinations there are. So I'm going to just build these water molecules and then see how many different ones I can get. And then number two, I want to figure out, well, how abundant is this one? This one's the most abundant, but that's qualitative, right? We want to be more quantitative. We want to be more quantitative. I want to know what is the percent, out of 100 water molecules, how many are going to be like this? It's going to be quite a big number, as far as percentages go, because this is high. And so I'm not going to give you the equation for determining that, because I know the percent of this, the percent of this, and the percent of this. This is in Appendix D. And where does this data come from Appendix D? Where did this data come from here? Did this come from theory, or did this come from observation? This came from observation. What instrument was used in determining the mass of the atoms, the number of isotopes, and their relative abundances, peak heights? What instrument was used? Mass spectrometer. Mass spectrometer. From the mass spectrometer, we get this data. This is all from observation. It'd be nice to be able to figure it out from theory, of course, but you'd have to get the theory, and it's not figured out from theory at this moment. Maybe somebody did, but anyway, so if I want to figure out the abundance, you have to think, okay, I got a percentage for the hydrogen, I've got a percentage for the oxygen, I got a percentage for the hydrogen, the second hydrogen. And I might just go ahead and multiply. You know what a percent times a percent gives you? A percent times a percent gives you a percent squared. Does that unit make any sense? Have you ever heard of a percent squared? Or let's do a percent times a percent times a percent. That gives you a percent cubed. Does a percent cubed make any physical sense to you? No, it's totally meaningless. And so what we might want to do is we might, instead of doing, let's say, this is dimensional analysis. Dimensional analysis, what unit do we want at the end? What unit I want at the end of the water molecule is I want to know the percent. What's the percent abundance for this, right? And so I just want 1% there. So maybe I might try a percent times what are other ways of representing a percentage? Like a decimal or fraction. So maybe I do a percent times a fraction. And the units for that would be a percent. And so that would be a hint as to figuring. So we don't know what the equation is, but we can kind of figure it out based on the units that we want at the end. Okay? And then having to factor in both of those. So why don't you continue with this. Let's try to get some kind of consensus with the number. I want to know the number of these. You don't have to worry about the grab bucket, 1,000,000 or 100,000. Just, I want to know the total number, and then we'll figure out, how abundant those should be. So why don't you work on them then? It wasn't a probability question. It was some other thing. It was like, the equations in the book, and it's like an engineering equation. A lot of engineering equations is given. You just plug in the number. But I think because I had more chemistry than the other people in the class, I took this class. This was an upper division engineering class, and I had to petition to take the class because I didn't want to take a prereq. So I was able to skip the prereq and then go straight into it. And it was a mixed class. It was a graduate and upper division class. And I think because most of the people in there, they only had like one semester of chemistry or something, or one quarter of the requirement for chemistry wasn't as high. So a lot of people weren't as familiar with dimensional analysis. But let's say I want joules. This was like the problem. It was much more complicated than this, but this is like the problem. Let's say the question is, I need to figure out this many joules, and the professor gave us this. The professor gives you, actually before I do this, I think I'm going to, let's say the professor gives you these. The professor gives you 4.18 joules per gram degree C, and then the professor gives you 500 grams, and they give you a T final of 500 degrees C and a T initial of 433. Actually, these aren't going to work. Let's say 50 degrees C, 50.0 degrees C and 43.3 degrees C. This was the problem. And then let's say you were never given the equation for this problem. Could you figure out the answer? Yeah, this is just dimensional analysis. The dimensional analysis is we want joules, so we need to get rid of what? I need to get rid of grams. How can I get rid of grams? Just multiply by 500 grams and then it cancels. And then, yeah, I multiply by my delta T, the change in temperature, and then I get it. So the situation was people were complaining they weren't given this equation, Q is equal to MC delta T, and therefore they couldn't figure out the answer. But you could figure out the answer just by using dimensional analysis. You don't need the equation, you just need to cancel out the units, correct? And so, I mean, when I looked at the problem, it was like this. I mean, it wasn't that hard. But I was surprised a lot of people didn't get it. And they didn't get it because they were expecting to have an equation. So I'm not going to give you the equation for the figuring out the percentage, and then see if you could figure it out. I gave you a hint already. See if you could figure out how to calculate the percentage for the water molecules based on the hint I gave you, or just use dimensional analysis to figure it out. That's the percent by mass. I don't want the percent by mass. I want the percent abundance. Yeah, that's correct for the percent by mass. So what I was just, H2O is about 11% hydrogen and 89% oxygen by mass. And that's a percent composition of water by mass. The percent composition by atom is different. The percent composition by atom is this. It's 67% hydrogen and 33% oxygen. And therefore, we have to say by mass or by atom or mole. We get a totally different percentage. But the percentage, we have lots of percentages, and so we got to keep track of all the percentages that we're dealing with. The percent I'm asking you for here is different, and I'm trying to get this. Even on the test, even though I go through this, still people get this as a percent by mass, unfortunately. I don't say 1 million grams, do I? I say 1 million atoms, 1 million balls. And yet people will still treat this as a percent by mass on a test. I don't know. Unfortunately, that's totally wrong. It's not a percent by mass. This is a percent by atom, and so they lose a lot of points just for that. And so a lot of these percentages aren't marked because people will say it's obvious. It's not so obvious, is it? It's not so. It's nice if they said this is a percent by atom, but here they aren't even going to say that because they expect you to know that it's a percent by atom. They don't expect to have to tell you that it's a percent by atom. Well, anyway, if I have 1,000,000 hydrogen atoms, how many are going to be H1? 999,885. If I have 1,000,000 water molecules, how many will be H1, O16, H1? You tell me the number. You know, if we know the percentage, or if we know the parts per million, or if we know the parts per billion, you could do parts per billion, or maybe even parts per trillion. But when we get to the least abundant one, you know, then it's not, you know, it's not going to be so easy because we don't have things memorized. You know, I have it up to 1 trillion, and then maybe it's a part per trillion. You know, once I go past 1 trillion, then I'll just add them. 1 trillion is 10 to the 12 times trillion is 10 to the 12th, so this gives you 10 to the 24. So that would be a trillion, right? So you tell me, you know, out of how many do we do 1 trillion? How many water molecules should we do, and then pick them out of the bucket? In other words, pick them out of the glass of water here. So why don't you work with other people and try? If you're getting stuck, then maybe you can join forces, or at least compare your answer with other people's. Try to do. But ultimately, we need the correct unit. This is why I say there's a big difference. In Chem 4, a lot of people ignore the units entirely. You can't ignore the units. If you're going to multiply something, you're going to add something, you got to keep track of the units. Some people will completely ignore it and they have no idea where they're going to go. But you can easily tell if you're on the wrong track, because if you get the wrong units at the end, then for sure you have the wrong equation. And so, for example, some people will get percentage squared at the end. Is that correct? Does percentage squared mean anything? No, it doesn't mean anything. It's absolutely meaningless. So what do we need at the end? So you might be hit with this type of question because, you know, when I was at UCLA, I thought, ooh, that was the hardest quarter ever. And then you know what happened the next quarter? It was even harder. And then it gets harder, and it gets harder, and it never ends. And you're going, when will it end? When will it get easier? It doesn't get easier. It just gets harder and harder. Well, as you go into more and more advanced classes. And so, you know, if you get stuck, you want to try, you know, just try something. And so this is like, you know, you'll start to see things that aren't so easy. It's not like plug and chug, like PV equals nRT is just plug and chug. But if it's just plug and chug, you can just have a computer plug and chug it for you. You know, you don't need a person. And so you need a person to make more, at least, you know, ChatGPT isn't there quite yet, and still gives incorrect. Maybe ChatGPT will be there, and then chemists will be obsolete, you know, at one point, but we'll see. I'm not quite there yet. So, did somebody have a percentage for the first one? Okay, what did you get? 99.73. Okay, let me write that down here. Your sig figs are off, though.
99.734057.
Okay, let me write that down. Seven three 047 057.
You just have 4 between 0. 734.
Okay. Did anybody else get that? You got the same? Okay. You got the same? Did anybody get something different? No? All right, why don't you do that for all the molecules and then make sure they combine to add up to 100%. And then rank them from most abundant to least abundant. I'm sorry? No, not yet. Later on, you do.
Have to buy our own, right?
Yeah, we might have extras. but you can buy them at the bookstore too.
Maybe like safety glasses, or does that mean goggles?
They have to be goggles. They have to have like splash protection.
As long as they have splash protection, they're fine.
Yeah. Any,
Openings that have the.
your what number are you on the wait list?
I believe there were 2 people in front of me, but I'm not sure if they ever showed up.
So I was like, okay,
I'm not too sure.
now you know.
Maybe 3. One of those.
Okay, let me take a look. We have to move from here, so probably Chem 108. What's your name?
Ashley?
Okay, there are 2 people, but one person I added, Rebecca, and so you're number 2. Waffle would be next, and then you.
Okay. So we're just waiting.
Like, yeah, can you access the Mastering Chem?
Yes, I believe so. I haven't done it yet. but
You
I
haven't
need
done it yet? Okay. Yeah, try to get it done today. And
Okay.
then you don't need to be registered, and you don't need to pay for Mastering Chem, so
Okay.
you'll be all right.
to. Sounds good.
Okay. And then I'll see about trying to get you in.
Okay, sounds good.
Hi.
I was gonna ask you, so for the exam,
Uh-huh.
you want us to like, you're gonna give us a table of eyes.
Yeah, right.
And then you want us to find
The number of different molecules, the percent abundance of the molecules, and the mass of the molecules. It might not be as complicated as water. It might be a diatomic molecule, which would be a lot easier.
can I use your pen to like,
Yeah.
I have the same question.
Yeah, for the mass spectroscopy type problems, that's what you do. You'd be given the table of isotopes because that's all observational data, and then you'd figure out the number of different combinations and what the percent abundance of each of those combinations are, and the masses of each combination by adding them.
Thank you.
Okay, those 3 things. I think the homework problem one is, they're only asking for, I forgot, but I think it's only 1 or 2 of those, and we need to do
or
3.
Chem 4 of you, or the next homework let's do?
No, the next homework that's due, not for the Chem 4.
Okay.
Yeah, this is not for the Chem 4 review.
Yeah, because I didn't remember seeing.
Yeah, this is for Chem 1A.
I'm just wondering, like, if I'm on the wait list, should I sign up for Mastering Chem?
Yeah, did you get my email? Check, I sent out an email to people on the wait list, and there's a link there to sign up for Mastering Chem. And you don't have to pay. They give you 2 weeks for free. So yes, the answer is yes.
I don't see the email.
Check your Canvas email. I sent it to the Canvas. Okay.
And it's mass of
Each molecule,
molecule.
yeah.
Professor, I had a question about how to prepare for the exam onward.
Okay, sure.
You mentioned P-Chem, the way you did well or they did well.
No,
was-
I didn't do well in PChem for the first exam. For the second exam, I pulled out of the nosedive
Yeah.
because I changed the way I studied drastically.
Exactly, and the way you mentioned is exactly the way I did well in Chem 4, is I just did all the problems.
Okay.
I suffered in the parts with memorization, let's say,
Well, the memorization stuff, you do what I just said today.
yeah,
You just read it. Reading the book every day is impossible, but reading your notes every day is
Yeah.
easy.
yeah, because I like that I can go back to your lectures and it's pretty clear. I can just write my notes, pause the video from the
Okay.
lectures we see today, and it acts as a way of trying to
Yeah,
remember
and
everything
then
we
once
talked
you
about.
get everything in your notes, then just read
Yeah.
read those every day, and you'll be fine for the memorization part.
Cool, yeah, that's
And-
the part I suffer at.
And then for the homework, if you do all the problems, make sure you get the complete solutions guide so you can check your answer. I don't really do the problems. I just read the question and then read the answer kind of thing.
Yeah, I always have to speed up my,
Mm-hmm.
because there's so many questions, I look at the answer key and then I try to get the answer via.
Yeah, that's
figure it out.
the best.
All right.
So the way you're doing is good.
Do we do any kind of like exam review, or sorry, exam review before the test?
We can,
So
we can do that. We can have a thing if you want, yes.
that sounds great, I love that.
Sure.
And then the quiz retake is gonna be Tuesday or Wednesday?
Wednesday.
Wednesday?
Yeah.
All right, sweet. All right, thank you, Mr.
Okay.
See you next week.
See you next.